All right, students, today we're going to look at section 6.1, which we're starting topic 6 on percentages. So hopefully this is going to be a very easy topic for you all. You've learned all about equivalent fractions, and we're going to work ourselves right on into percents by using what we know about equivalent fractions. All right, Tom made a vegetable pizza and a pepperoni pizza. He cut the vegetable pizza into 5 equal slices and the pepperoni pizza into 10 equal slices. Tom's friends ate 2 slices of vegetable and 4 slices of pepperoni. So down here in part A, so we need the vegetable pizza. Vegetable, we need to break it into 5 equal pieces and the pepperoni into 10 equal pieces. So let's take a moment and do that. Now, this picture is already drawn for you. I wouldn't have done it this way. I would have put one rectangle underneath the other because we can compare things lined up this way easier than sideways. But we're going to do it anyway. Okay, so I'm going to have to play with this just a minute until I get these kind of equal. So, there's 1, 2, nope, that's not big enough. So I want to make that a little bigger. 1, 2, 3, 4, 5. That's pretty close. Vegetable pizza into 5 equal sizes. So 1/5, 1/5, 1/5, 1/5, and 1/5. Okay, so I'm going to do the same thing. I'm going to make 5 over here. 1, 2, 3, 4, 5. And then I'm going to put 1 in between there. 1, 2, 3, 4, 5. Now there should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one is in tenths, and this one is in fifths. Okay, now I'm going to shade. I'm going to shade 2 of the vegetable. Shade here and shade here. That's how much they ate. And then I'm going to shade 4 of the pepperoni. So there's 1, 2, 3, 4 of the pepperoni. Now see, if this was one underneath the other, you could see if this lines up or not. But remember what we did. We had this in 5 pieces, and then we went back through and we separated that out and made each one of these 2 more. Yes, or 1 more. So here is 2/5 right here. This is 2/5, and this is 4/10. 1, 2, 3, 4. But isn't this really 4/10 also? And here's how we know that. I'm going to come down here and we're going to say, Tom says his friends ate the same amount of vegetable pizza. Did they? Did they eat the same amount as pepperoni? Well, let's see. Does 2/5 equal 4/10? Let's see if it does. What do we know about equivalent fractions? If I multiply this by 2, I get 4. If I multiply this by 2, same number, I get 10. So these are equivalent fractions. And because they're equivalent fractions, we know that they ate the same amount. All right, let's go down here to focus on math practices. What if Tom's friends ate 6/10 of the pepperoni pizza? How could you use the rectangles above to find an equivalent amount of vegetable pizza? 6/10 is going to equal what in fifths? Well, 2 times this number gives me 10, so this would have to be 3 to make it equal 6/10. So if we come up here, if we did 2 more of these to make it 6/10, then we would need 2 more of these, which would be 1, 2, 3/5. Yes? Okay. So what if Tom's friends ate 6/10 of pepperoni pizza? How could you use rectangles? You'd add on 2 more rectangles, so it would be two of these rectangles make 1 of these. So that would be another 5th added on. Okay, let's go to example 1. Now example 1 is pretty much worked out for you. We're just going to read along and follow. At the top there's an essential question. How can you represent a rate with 100 as a whole? What percent of people prefer bright white toothpaste? Here is your definition of percent. You're going to need this when you do your vocabulary. A percent is a rate in which the first term is compared to 100. The percent is the number of hundredths that represent the part of the whole. Modeled with math, decimal grids, number lines, or equivalent fractions can be used to represent percents. Here's all the different ways we can do percents. Over here it says 7 out of 10 people prefer bright white toothpaste. 7 out of 10. Well, as you can see, that 10 right there, let me get my ink pen. 7 out of 10. 10 is not 100. So, they're saying, well, I can't call that a percent. How do I change 7/10 to a percent? Well, if I multiply this number by 10, I get 100. If I multiply this number by 10, I get 70. So 7/10 is equivalent to 70 hundredths, and 70 hundredths is written as 70%. When you say the percent symbol, that means out of 100. So right here it says you can use the percent symbol to represent percent. So that means out of 100. Okay? Another way, use the number lines to represent the percent. Here is the whole base of 10, and here's the same length of a number line, only this time it's in 100. You put that in equal increments, and this right here is going to line up, and so 7/10 is the same as 70%. Now, I don't know about you, but I don't want to draw number lines all the time. Here's yet another way. Use an equivalent fraction to find the percent. And this is what I did a minute ago. 7 times 10 is 70. 10 times 10 is 100. When it looks like this, then you can write it as 70%. Okay, let's go to the try it. Jane won 9 out of 10 video games she played. 9 out of 10 videos she played. This is a part and this is a whole. Okay, what percent? So we want to know the percent. When it's 100, what's this number going to be? So if I multiply this by 10, I get 100. If I multiply this by 10, I get 90. So it's 90%. All right, let's go to example number 2. Examine percents and wholes. Each line segment represents 100%, but the segments are not the same length. Use equivalent rates to find the percent or part of each line segment that points A and B represent. Okay, so this is all of this line. If this whole line, the whole length is 2 inches, and this is at 1 inch, then the whole thing is 100%, so this number is half of that number, so this would have to be 50% because it's half of 100%. Okay, so a half right here turned into 100%. 1 times 50 is 50, 2 times 50 is 100, so it must be 50%. Now, on the next one, they want to know, where's point B? Where is point B? Well, let's see. Here's 1, 2, 3, 4 inches is the total. So 4 inches is 100%. 4 inches is all of it. So we're going to take, let's see, that's 1 out of 4. 1 out of 4, 1/4, but we're going to turn it into percent. So we have to multiply 4 quarters to get 100 and multiply 1 times a quarter to get 25. So it must be 25%. Okay. Try it. Which point represents 50% on the second line? 1, 2, 3, 4. Well, 2 is half of 4, so it must be point C. It's halfway. Okay, let's go to example 3. Use percents. You can use percent in mental math to find the length of a line segment. If CD represents 10%, what is the length of a line segment that is 100%? So let's see, this is 10%. So there would be 10 of these in 100%. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's 10 of these right here, and each little piece is 4 inches. So we got 4 and 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 4. Yes? So I need 1, 2, 3, 4, 10 of those times 4 inches. So I need 10 times 4, or the whole length right there is 40 inches. 10% is 4 inches, so the whole thing had to be 40 inches to begin with for a tenth of it to be 4 inches. Okay. If EF represents 200%, so this one right here is 100%, and this one is 200%. What is the length of the line segment that is 100%? So this is 2 100%, so this has to be half the length of that one, so this has to be 3 inches. 100% is half of 200%, so the length of the line segment is half of 6, which is 3 inches. Try it if CD is 100%. So if this is all of it, then what is the length of a line segment that's 25%? So I want 25% is a fourth. I want a fourth of 4 inches. I want a fourth of 4. So it would be 1 inch. Going the other way. Because 100% was 4. And I want a fourth of that. 25% reduced is 1/4. So I wanted a fourth of 4 inches. 1/4 of 4 inches. All right. Turn your paper over. Key concept at the top of the page. A percent is a rate that compares a part to a whole. The second term in the rate is always 100. The whole is 100%. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 boxes this way, 10 boxes this. This is 100 boxes, which means 100%. The whole thing is 100%. But the shaded part is 1, 2, 3, 4, 5, 6. 6 times 10 is 60. So the shaded is 60 out of 100. 60 out of 100, which is 60%. Okay? All right, let's go right on to the do you understand. It'll get easier as we go. How can you represent a rate with 100 as the whole? Percent is the number of hundredths. Percent is the number of hundredths that represent the part of the whole. that represent the part of the whole. So we're going to use percent. Number 2, when writing a percent as a fraction, what number do you write as the whole or the denominator? It's 100. Every time there'll be 100 in the denominator if you're talking about percent. Okay, number 3. Why are tenths, fifths, fourths, and halves easy to express as percents? Because they are all factors of 100. Number 4, why is the grid in example 1 a good way to represent a percent? The grid has 100 boxes. Okay, number 5. If CD in example 3 is 100%, is the length of a line segment that is 300% longer or shorter than 4 inches? It's longer by 3 times. Every 100%, this is 100%, and it's 4 inches. So I got another one. There's another 100%, and it's 4 inches. Then I got another 100%, because it was 300%, and it's 4 inches. Okay? So it would be 1, 2, 3 times 4, so it would be 12 inches long. Every one of these represents 100%, 100%, 100%. 1, 2, 300%. Each one of those is 4 inches. So it would be 3 times 4 or 12 inches for 300%. Okay, let's go to number 6. Do you know how? Write the percent of each figure that is shaded. Okay, first of all, we got to know how many divisions there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's 1, 2, 3, 4. So there's 4 out of 10 that's shaded. Now we need to turn that into equivalent fraction that has 100 on the bottom to get it in percent form. So 10 times 10 is 100. 10 times 4 is 40. So it's 40%. Now we can write it as 40%. Equivalent fractions. On number 7, we need to count the blue boxes. 1, 2, 3, 4, 5, 6, 7. 7 out of 100, so that is 7%. Now, why didn't we have to get an equivalent fraction? Because the denominator was already 100. When your denominator is 100, then you can say the numerator as percent. Number 8, find the percent. 1 times what gives me 20? Well, it's 20. So when I multiply top and bottom, numerator and denominator, by 20, now that is 100. So how can I write 20 over 100 as percent? It's just 20%. Percent, when you say the word percent, that means that the fraction was written over 100. Number 9, 3 times 10 is 30. 10 times 10 is 100. 30 out of 100 means 30%. You can't say it in percent form like this until you get the fraction to be something over 100. Number 10, I'm trying to get to 55. So 11 times 5 is 55. Use the same 5 down here. That's 100. So this must be 55%. All right, number 11 refers back to example 2. Find the percent of the line segment that point D represents in example 2. So let's go look at example 2. We're looking at point D. So, and we wanted the find the percent of the line. So there's 1, 2, 3, 4 sections. And it's at the third section, so 3 out of 4 sections. All right, I'm going to turn this back over. So we want to take 3 out of the 4 sections, and we want to make this bottom number be 100. Well, what do you have to multiply times 4 to get 100? So it's 25. So 4 times 25 is 100, and 3 times 25 is 75. So that's 75%. I need to see this, and I need to see this. We're comparing every piece of something. We're comparing and changing it into a percent. And on percents, the bottom, the denominator has to always be 100. Okay. Now we're on page 351 of the workbook. Here's your practice in problem solving. You're going to use all the examples that we've been through and all the explanations to work the problems on this page. So the rest of your time today will be spent working problems 12 through 19. You try it by yourself. Make sure you go back and look at everything we've already done before you ask your classroom teacher. You always, always, always try first yourself. Okay, get busy, and I'll see you tomorrow.